Okay, today's video is all about the line of sight and also how light reflects. Two objectives I want you to focus on as you watch this video is being able to describe how light is reflected from an object and also explain how our eyes see reflected objects. A ray of light is actually an extremely narrow beam of light, and it comes from all of the different objects. All visible objects are capable of either emitting or reflecting light rays in all directions. Right now on the screen is just a few of the infinite number of light rays that are possible. Here's the no-duh statement of the video. We see images when light rays converge towards our eyes. This is called the line of sight principle. In order to see something, you have to be looking at it, and you have to be sighting along one of those rays that are being emitted from the object. It's very important to note that the light is leaving the object and entering your eye. The converse is not true. Light does not leave your eye so that you can see the object. You'd be surprised how many people actually screw that up. When light reflects off of a surface, it follows the law of reflection. All waves, including light, bounce off of surfaces, and when they do so, they reflect at the same angle as they came in at. It's important to note, though, that the angle is measured relative to that normal line. So theta I and theta R are always going to be equal to each other no matter what. Here's a really cool picture that kind of shows light reflecting off of multiple surfaces. Okay, so you can see the light leaving the laser kind of down on the bottom right-hand side, and then look at all of those angles as they're reflecting off of the surface. All objects are capable of reflecting light. How they reflect the light impacts what we see. So you have two different images on the bottom. Okay, the one on the left is really clear to see. You've got the surface, or you've got the image of those buildings reflected in the lake. What do you think that image is on the right? Well, it's actually a piece of paper, and pieces of paper are capable of reflecting light. The difference is how they're reflecting light. Specular reflection is when light bounces off of the surface and all of those rays of light are parallel to each other. They also reflect parallel. Diffuse reflection happens off of a rough surface. So all of those beams of light are striking, but because the surface is rough, they bounce off in all different directions. Keep in mind that with diffuse reflection, each individual ray still obeys the law of reflection. Mirrors obviously reflect light rays. Okay, here's our same candle again, and the dark orange lines are showing some of the light rays emitted from the candle. When they strike the surface of the mirror, they reflect in such a way that if there's my normal line, the angle of incidence equals the angle of reflection. We have lots and lots of different possibilities coming from the surface of the mirror. We're only looking at a few of them. Okay, so how do I know whether or not I can actually see that image in the mirror? Based on that line of sight principle, your eye would have to be located along one of these reflected rays. So you'd be looking into the mirror following that straight line path. There's two different types of mirrors that are capable of reflecting light. Okay, the first one is a plane mirror, and a plane mirror is basically just a flat mirror that reflects light rays in the same way that they approach the mirror. So every single angle measured is going to be the exact same. Concave mirrors is a converging mirror where light strikes the mirror and then reflected so they converge or come together at a single point. For now, we're going to focus just on the plane mirrors. What I want you to do is hit pause and go stand in front of your bathroom mirror or any other mirror and take a look at yourself. Okay, write down what you see as far as your image and then come back and let's see what you came up with. Here are some characteristics of what you should have seen about yourself. There's what's called a right-left reversal. Okay, I have an asterisk on that because it's not really reversing your left and right hand. It's just showing you what you would see from the perspective of somebody behind the mirror. So when you raise your right hand, it appears as if your image is raising its left hand. Still your right hand, it's just from a different perspective. Okay. Did you also notice that you stayed the same size? Did you notice that you were the same distance away from the mirror as your image was from the mirror? Okay, one you might not know is that you were looking at what's called a virtual image. A virtual image is an image that is formed in locations where light does not actually reach. Okay, so how is an image formed and how do we know where the image is located? So watch this animation to find out. So the light leaves the image and it's going to reflect off the mirror according to the law of reflection. The image is the location where all of the reflected rays trace back and converge. So where all of those reflected rays trace back, that's where your image is at. Okay, what this is showing you again is just an example of a ray diagram showing where you can locate an image. There's the incident rays, there's the reflected rays. You take the reflected rays and trace them backwards to locate your image. To draw a ray diagram for a plane mirror, one ray that's useful to draw is a ray that strikes perpendicular to the mirror surface. It's always going to reflect perpendicular to the mirror, and then a reflected ray would extend back beyond the mirror to be able to find where that image is at. Another useful ray that strikes a mirror at any angle, and the angle of incidence equals the angle of reflection. Again, the reflected ray is extended beyond the mirror to locate the image. Let's look at this example. Okay, so the ray that's traveling perpendicular to the surface, when it strikes that mirror, since it's already bouncing at a 90-degree angle, it's going to reflect back on itself. The second one is at an angle. When it reflects, it's going to obey the law of reflection, and as best as I can draw it, I'm showing that those angles are equal. Those reflected rays get traced backwards behind the mirror. I'm drawing them as dotted lines because light doesn't actually travel behind the mirror. Okay, what this gives me is my image location. Okay, so those two rays trace back to actually form my image. Let's look at another example. Okay, so here I've got my object, I've got the mirror, and I've got my eye. What I want to be able to do is draw a simple ray diagram that shows what it is that we're able to see in the mirror. This one I'm going to do a little bit different than the previous example. Okay, I'm going to start and I'm going to draw a ray leaving that object. If I want to be able to see it, it needs to reflect in such a way that it travels back towards my eye. So again, it left the object, traveled towards my eye. Now, if I'm looking at the mirror, I can see any of those rays that are acting along that surface of the mirror. So what I'm going to do is I'm actually going to think backwards. For me to be able to see this image, I need to have a ray bounce back to my eye from the very edge of the mirror. Now that's the reflected ray. This would be the incident ray. So it left the object, hit the mirror, and traveled towards my eye. Now here's a question for you. Can I actually see the entire object in the mirror? That answer is no. I can only see this portion of the object. There's not a ray leaving the tail end of the arrow to hit the mirror and travel towards my eye. We'll do more with ray diagrams the next time that I see you. Again, if there's any part of this video you need to rewatch, rewind, and please do so.